This video is on graphing radical functions. The function f of x equals the square root of x is the parent of the square root function, and its graph looks like this. You'll notice that it starts at the origin and heads off to the right and goes up slowly. Here's a table of values. You'll notice that as I chose the x's for my table of values, I didn't choose consecutive integers. Instead, realizing that y was going to be equaling the square root of x, that whatever number I put in for x I had to take the square root of. That's why I chose perfect squares here, so that I would get integral values of y. You can choose whatever numbers you'd like, but just make sure that it's easier if they're nicer numbers to work with. You'll also notice that x cannot be a negative number because in the realm of real numbers I cannot take the square root of a negative number. So my domain is restricted to x is greater than or equal to 0. That's also going to restrict my range to values of y that are greater than or equal to 0. The function f of x equals a times the square root of x minus h plus k represents transformations of this function. Its vertex, or its starting point, is the point hk. You'll notice that h is the number that's being subtracted from x underneath the square root sign, and k is the number that's added onto the end. These transformations are similar to those that we saw for quadratic functions. If a is a positive number, as x approaches positive infinity, f of x also approaches positive infinity. That is, the graph opens up and to the right. If a is negative as x approaches positive infinity, or as x gets larger, f of x or y gets smaller. The graph will open down as it moves to the right. In other words, the graph is basically reflected over the x-axis. If the absolute value of a is between 0 and 1, that is, if a is a fraction, the graph is vertically compressed. It's narrower and is closer to the x-axis. If the absolute value of a is greater than 1, the graph is vertically stretched, so it's wider and further from the x-axis. And as with quadratic functions, h and k determine translations left or right. If h is negative, translated h units left. If h is positive, the graph is translated h units right. If k is negative, the graph is translated k units down. And if k is positive, the graph is translated k units up. Let's take a look at an example here. So here we need to graph f of x equals the square root of x plus 2 minus 3. Then we need to describe how it's a transformation of the parent function and state its domain and range. First thing I notice is that h is equal to negative 2. Remember, h is the value that's subtracted from x, so this is actually x minus a negative 2, and k is negative 3. So that means that this graph is going to be translated 2 units left and 3 units down from the parent function. That's going to give me my vertex, or my starting point, of negative 2, negative 3, which I'm going to go ahead and graph here. Okay. Now I'm going to make a table of values to get some other points here. And my starting point is negative 2, negative 3. And I'm going to think about what values of x I want to choose, because I would like to have a perfect square underneath the square root sign here. So when I have negative 2, I have the square root of 0, which is perfect. I'd like to have the square root of 1. So in order to get a 1 in there, I need to have x as negative 1, and that's going to give me a y value of negative 2. I'd like to have a 4 underneath there, so that means I'm going to have x equals 2. And that's going to give me a y value of negative 1. And then I'd like to have a 9 under there, so x equals 7, and y is going to equal 0. You don't have to choose these numbers. I could have chosen, 0 and 1, but that would give me decimals. So as long as I have the ability to choose my own numbers, I'm going to choose numbers that I find easy to graph. And 7, 0. And since a is equal to 1, positive 1, it goes up and to the right like that. My domain is x is greater than or equal to negative 2, and my range is y is greater than or equal to negative 3. All of my x values are getting equal to negative 2, or they're getting larger, and all of my y values are equal to negative 3 or getting larger as well. The function f of x equals the cube root of x is the parent function of the cube root function, and it looks something like this. You'll notice that this is different from the square root function because it not only has this portion on the right that goes up and to the right, but it also has a part that goes down and to the left. You'll also notice that I can actually plug in negative values for x because the cube root, if I put negative 27 in here, the cube root of negative 27 is negative 3, just as the cube root of 8 is going to be 2. Again, I chose x's that would give me integral values of y. So the domain of this function is all real numbers and its range is all real numbers. The cube root function can also be transformed in the same way as the square root function, and the function that represents these transformations is f of x equals a times the cube root of x minus h plus k. Let's take a look at an example of one of these. I need to graph f of x equals the cube root of x minus 3 plus 1. Describe how it's a transformation of the parent function and then state its domain and range. Well, I notice that h is equal to 3 and k is equal to 1. So this is going to be translated 3 units right and 1 unit up from the origin. So I can graph the point 3, 1. Now remember, that's not really a vertex, that's not a starting point. Part of the graph is going to go, since a is positive, is going to go up and to the right, and another part's going to go down and to the left. So in making my table of values, I think I'm going to put that point in the middle, and I'm going to choose two values of x that are smaller. 2 will actually work in there, so the cube root of negative 1 is negative 1, which gives me 0. And then I think I would like to have a negative 8 under there, so if x is negative 5, then that's going to give me a y value of negative 1. And I can choose 4, and that will give me 2. And then if I want to have a positive 8 under there, I need to have x is equal to 11, which is not going to fit on my graph, and y will be equal to 3. So let's go ahead and graph those points. So I have 4, 2, and 11, 3 is going to be out there somewhere, so I'm not going to worry about that. 2, 0, and negative 5, 1. So my graph will go like this, and head off like that. Yeah, actually maybe this part goes up a little too high too fast. I think it's probably more like that. Okay, so my domain of this is all real numbers, and my range is also all real numbers. So in this video, we took a look at how to graph radical functions, specifically the square root function and its transformations, and the cube root function and its transformations. We also took a look at how to determine what those transformations are by looking at the function equation, and how to determine the domain and range.